Hello, my name's Eleanor and I'm the Education Manager at Benjamin Franklin House. Thank you so much for joining us for this week's live science class. We're going to be looking this week at Ben Franklin and the Gulf Stream. Now, if this is your first time joining us live, I'll tell you the ways that you can participate, so either asking or answering questions. So there are two ways that you can do this. The first way is if you tap your screen or click your mouse, you should get a banner at the bottom of the screen with some icons. And one of those will be a raise hand button, which has an icon of a hand. And if you press that, then my friend Caitlin, who also works at Benjamin Franklin House, will be able to unmute your microphone, and then you can ask your question over the audio, and I'll do my best to answer it. The second way that you can ask a question live is to use your Q&A button. So once again, if you tap the screen or click your mouse, then you'll get that banner appearing. And one of the icons should be two speech bubbles. And if you press that, then you should be able to type your question and Caitlin will be able to read it out and I'll try my best to answer it. We are also recording today's session, so if you're watching this on YouTube, then you can always leave a question in the comments. And we love to receive questions or feedback or photos of you doing demonstrations as well, which you can always send to via email to education@benjaminfranklinhouse.org. So today's topic is the Gulf Stream, and this lesson is a bit different to ones we've done in previous weeks because Ben Franklin didn't invent the Gulf Stream and he wasn't even the first person to discover it. So the first time it was written about was over 200 years before Ben Franklin started working on it, and that was in the records of a Spanish explorer called Juan Ponce de Leon. But the reason that we think about the Gulf Stream when we think about Ben Franklin is that he was really the first person to make an official map of the Gulf Stream, which became really important to people traveling in ships, which was really the main way that you could travel long distances in those days. So, before I tell you more about this story, I wonder if anyone's heard of the Gulf Stream before and thinks they could explain a bit about what it is, or if someone wants to have a go at having a guess, maybe using the picture of the map that we've got up on the screen. Now, this is Franklin's map. It's not the original one he did, but one that was made about 10 years later that shows the Gulf Stream. It's the dark grey part of the map. I wonder if there's anyone who'd like to try raising their hand or writing in the Q&A box what they think the Gulf Stream could be.
A question was asked, is it a river?
That's a really good guess. It looks like a river on this map, doesn't it? And it is to do with water. So if you look under the grey part, you might see the word Atlantic Ocean. So it's actually an ocean current, and I'm going to explain. So it brings warm water from the Gulf of Mexico, and it goes all the way up the east coast of the United States and then comes round to Europe. And I'm going to be explaining more about the science of how it works later in the lesson. But first of all, I'll tell you the story of how Ben Franklin came to be interested in the Gulf Stream. And also on the screen, we've got some writing, and that's something that Ben Franklin said, where he's describing how he gave the order for the chart to be officially printed as an official map. Okay, so the main reason that Ben Franklin first became interested in the Gulf Stream was that he actually crossed the Atlantic Ocean, which we can see on the map, 8 times in his life. So that was 4 round trips backwards and forwards to and from America. So I wonder if, thinking about the fact that Ben Franklin was born over 300 years ago, does anyone know what sort of ship he would have had to go in those days? How would it have been powered? And also, how long do you think that would have taken to cross the whole of the Atlantic Ocean to get to England or other countries in Europe? I wonder if anyone has any ideas about those questions. So what kind of ship and how long do you think it would have taken? You might find some clues in the map.
No raised hands or chat or Q&A, unfortunately.
No problem. So if you look at the grey part of the map, and underneath it actually as well, you can see some little drawings of boats. So these are big sailing ships. So at the time, they didn't have electronic motors yet, so they would have had to use sailing ships. And it took a long time to cross the Atlantic Ocean, but about 6 weeks. So if you think Ben Franklin did it 8 times, he spent quite a lot of time at sea. So he always kept busy and was always interested in science. So that's how he came to be quite scientific about the Gulf Stream and wanting to know more about it. So on your screen now, you should be able to see two other images. So on the left, that's an illustration of this journey that Ben Franklin took so many times across the Atlantic. And this drawing was actually made by Kromina Dimitrova, who's our illustrator in residence at Benjamin Franklin House. And she created this amazing sticker book for us, which is where this picture is taken from, all about Ben Franklin's time in London. So if you're interested in finding more about that, you can have a look at our online shop on our website. And then the other picture on the right, this is an artist's impression of what it would have looked like when Ben Franklin arrived back home in Philadelphia after his final trip to Europe. So you can see the big sailing ship with all the sails. And this artist wasn't actually there at the time. He did this painting later, but it's an idea of all the people welcoming the famous American Ben Franklin back to his home city of Philadelphia. And at the bottom, there's more writing from Ben Franklin, so it's from the same letter to a friend of his that we saw the writing from before, and it's explaining how really the great thing about the Gulf Stream was it helped Ben Franklin to understand how ships could travel more quickly across the Atlantic, so between England and America or other countries in Europe and America, and that was very interesting to Ben Franklin and lots of other people, which is why this map was so useful and important. So, as I said, Ben Franklin made lots of trips across the Atlantic, and I'll just let you know the different times he made that journey. So the first time was in 1724, and that was when he was just 18 years old, and that was his first time in London, and he came to the big city of London to help learn more about printing, because that was his first job, and that was how he made his fortune before he went on to become a famous scientist and politician. So that was the first time. The second time was in 1757. Ben was a bit older, he'd become more famous by that time, and he came back to London, this time as a politician, as a diplomat. And that's when he came to live at 36 Craven Street, which is the house we now know as Benjamin Franklin House, and I'm going to show you a picture of it in a moment. So he came in 1757. He was in the house for a long time, for 16 years, but he did go back to Philadelphia in the middle. So that was the third trip back and forth. And then he had to leave London in 1775, because that was just before there was something called the War of Independence between America and England, when America broke away from being ruled by England and became an independent country. And then his final trip back to Europe and then back to America was in 1776. So this time he went to France, and he was the first American ambassador to France. And he did a really good job of convincing people in France that they should help the Americans fight against the English in the War of Independence. So lots of journeys across the ocean and lots of things that Ben Franklin was doing. So as I said, he was a busy man, and he liked to keep busy. So on those long journeys, he kept doing his science. We know that he measured the temperature of the water, of the seawater at different points of his journey, and also made quite scientific observations of what the water looked like as he was traveling across the ocean. Now, it was during his third stay in London that he decided to really get to the bottom of what the Gulf Stream was. So I'll tell you the story of how that happened now. So now on the screen, you should see some more pictures. So on the left, we have 36 Craven Street, or Benjamin Franklin House. and that's where Caitlin and I are normally. So if you haven't been to visit us there, then I really hope you'll be able to when we reopen. And then there's pictures of two men. So Ben Franklin's in the middle, and this portrait's actually at the National Portrait Gallery, which is just around the corner from Benjamin Franklin House, so you could always go and see it if you came to visit us. And then on the right is another gentleman who's not as well known as Ben Franklin. He's called Timothy Folger, and he was Ben Franklin's cousin. And he's a really important character in this story of how Ben Franklin came to create the map. So I'll tell you a bit more about him. Now, when Ben Franklin was in London, as I said, he was a politician, he was working as a diplomat, but he was also given another special job, which he was given by the King of England. It was a king at that time, which was the Deputy Postmaster General for the colonies. I wonder if anyone might know what that means, or could have a guess at what that job could involve. So the name of his role was Deputy Postmaster General for the colonies. I wonder if anyone could have a guess at what that means.
We have a raised hand from Jessica.
Hi, Jessica.
Hi. My guess is that he ran the post office.
That's brilliant. You're exactly right. He was in charge of all the post in the colonies, which was at that time, that was what some people called America. So before America broke away and became independent, it was sometimes called the colonies. So yeah, exactly. Ben Franklin was in charge of making sure all the post got to where it needed to be, and also trying to make sure that it got to its destination safely and as quickly as possible. So that's what really got him thinking about the Gulf Stream, because he heard that some of the ships that were carrying letters from England to America were actually taking longer to get there than other ships, than American ships that were merchant ships, so they were selling things, were taking to do the same journey, which he thought was a bit strange, and he wondered if it was something to do with this Gulf Stream. So he went to visit his cousin Timothy Folger, because Timothy was a seaman. He was one of the sailors on those merchant ships, and he'd grown up in a place called Nantucket, which is an island off New England. And Nantucket is well known because it used to be a real center for the hunting of a big sea creature that was very popular at this time. It used to make people a lot of money. But we can't hunt these big sea creatures anymore. They're really the biggest thing you might find in the ocean. And it's now against the law to hunt them, but at that time it wasn't. I wonder if anyone might be able to guess what sea creature I'm thinking of. So the biggest sea creature you can find in the ocean.
We have another raised hand from Jessica.
Hi again, Jessica.
I think it's whales.
Absolutely.
Is it whales?
Yeah, you're right. It's whales. Exactly. So whales used to be very valuable. They used to take all sorts of things from them, including some oil that they used to use in the lamps before they had electricity. And so Timothy, before he was a merchant sailor, he used to be involved with what they call fishing. And so he was able to explain to Ben Franklin that those whalers, the people that hunted the whales, they had known about the Gulf Stream for a long time, and they used it to help them catch the whales. And he explained that the reason some of those English ships that were carrying the post were taking longer is that they didn't understand the current that was the Gulf Stream, and they were trying to sail against the current, so it was harder for them. So from that conversation with Timothy, Ben came to understand that if a ship was traveling from America to England, then it should use the current to travel faster because it's going in the same direction. But if the ship was going the other way from England or other countries in Europe to America, then it needed to try and avoid the Gulf Stream because the current was going in the opposite direction, going harder. So with Timothy's help, he managed to sketch a design of the map of where the Gulf Stream was, and he printed it in London in 1768, and then that came the official map of the Gulf Stream, and he straight away went and gave it to all those ships to take the coast to England, and later when he went back to France, he also gave it to the French so they could use their warships to with war independence. So now we've heard that story and the history of Ben Franklin and the Gulf Stream, let's have a think about what the science behind the Gulf Stream is, how it works, and why it's still so important today. So now on your screen we should have two more pictures. So on the left we've got a modern map of the Gulf Stream. So to help us understand how it works, let's first think about whether you can explain what happens when air gets heated. So you might have seen this happening to air above a radiator, or thinking about what happens to the heated air inside a hot air balloon. Can anyone explain what happens to air when it gets heated? So what would happen to a hot air balloon? There's hot air going into the balloon, and then what happens to it?
No raised hands or comment in the chat.
No worries, it's quite a tricky question. So when air is heated, it rises. So that's why the hot air balloon goes up in the air, because the air inside the balloon is getting heated. And if you watch carefully over a radiator, I know it's getting into summertime now, so they might not be on, but in the winter you might be able to see the patterns of the air above it rising as well. So, so air rises when it's heated, and so does water, and that's what's happening with the Gulf Stream. So the Gulf Stream starts by Mexico, which is near the equator, which is where it's the hottest point in the earth, and that water gets heated by the sun, and then it rises to the surface of the ocean, and it gets pushed along by winds, and so it goes all the way up the east coast of the United States and comes round towards Europe. And part of the reason that it rises is that the water is becoming less dense. So that means that the tiny little particles inside it that it's made up of are spreading out and taking up more space. So it rises and then moves towards Europe. And it's moving at about 2 meters per second and bringing over 100 million cubic meters every second of water into Europe. So it's this really big movement of water. And then when it gets there, it cools down again and becomes denser again, and then sinks back down and returns around. So a bit like a conveyor belt. So the Gulf Stream is still really important to us today. Does anyone think they could have a guess at what effect it might have on our climate in Europe? So what the weather's like in Europe? What do you think this warm water could do to the climate in Europe? They're quite tricky questions today, but I know Caitlin will let me know if anyone's got their hand up or wants to say from the Q&A. So it really helps to keep the climate warmer in Europe. So if the Gulf Stream stopped, then the temperature would fall by at least 5 to 10 degrees Celsius. So if that were to happen, then we'd have much longer winters in Europe, and it would be a lot more snowy and icy. And some scientists are actually worried that that could happen because of climate change, because of global warming. Because if the ice caps near the North Pole keep melting, then that would disrupt the current and might stop it, which would cause all sorts of problems, particularly for us in Europe. So that's why I've put up the Sustainable Development Goals on this slide too, because thinking about the Gulf Stream really reminds us how it's really important that we work towards achieving those. So if you haven't seen them before, they're the colourful squares on the right of your board, and they are some 17 goals that were set by the United Nations in 2016, and lots of countries have said they're going to try and achieve these goals by 2030, and they're trying to do that to make sure that the planet is a safe place for everyone, and that the planet itself is protected. So thinking about the Gulf Stream, to protect it, we need to really think about that SDG 13, which is climate action, and because that's going to have a big impact on SDG 14 and 15, which is life underwater and life on land as well. So lots of things to be thinking about. Right, so now we've looked at the Gulf Stream, let's look more closely about how this current is happening, because it's one type of heat transfer, and there are two other types which I'm going to tell you about as well. So heat transfer is when there's a temperature difference between two objects, and energy gets transferred from the cooler object to the hotter object. So there's three different ways this can happen. So the first one in the picture on the left is conduction. So this is normally happening. You might have heard that word before, and I know we spoke about it when we did our session on electricity. So this is normally in solids, and you can see someone's holding a metal rod over a candle, and the red is hopefully helping you to see that the heat is spreading along the metal. So what's happening inside that metal is that the little particles that make it up are gaining energy, and they're starting to move around more quickly and bumping into each other, and then passing that energy along the material until it gets to the cooler end. And when it has reached the cooler end, it reaches something we call a thermal equilibrium, which is like, equilibrium is like balance. So everything's balanced again rather than having this difference in temperature. Now the second one is convection, which is what we were talking about with the Gulf Stream, but this example shows you that air in a convection current. So this is happening every day on Earth, that the air near us on the surface gets heated up by the sun, and then it rises up into the sky and then cools down again. It's much colder up there, and then it will come back down because it's got cool again. And then radiation is the third type, and this one's quite different because it doesn't need particles for it to happen, which is why it's the way that the heat from the sun actually travels through space to get to us on Earth. So another really important one. Okay, does anyone have any questions about any of those things before I move on to show you our demonstration for today? Do feel free to raise your hand or put anything in the Q&A box if you're wondering. So I'm going to stop sharing my pictures, and I'm going to show you the demonstration. So we're going to be making our own convection current at home. So I'll show you first what you're going to need. You're going to need a quite large plastic container, and I've put a piece of paper, just stuck it at the back, but that's mainly to help you see on the video. But it might help you too. So I've filled this almost to the top with water. And then the other things I'm going to need are a tea spice jar. And so ideally one that's got these holes in the top, so a few different holes in the top. Some food colouring, any colour really, but if it's a bold colour like pink or red or green or blue, that will probably work best. You're also going to need a kettle with some water in it. And then an optional one is to have some ice. I'm going to use this at the end, but don't worry if you haven't got ice, because that's a bit of an optional one. Okay, so we're going to see, we're going to show that when water is hot, it does rise. And can anyone remember why that happens? What happens to the water? So the particles start to move apart from each other, and that means the water is getting less. Do you remember the word to describe it? It's getting less dense. Okay, so it's getting less dense and it's rising. So I'm going to show you that with the simple apparatus today. So once you've got all the apparatus ready, the next thing you need to do, and you do need to ask, and it's really important you ask an adult's permission for this, and probably do it with them, because you're going to need to boil some water in a kettle, and obviously boiling water can get very hot and we don't want anyone to hurt themselves. So once that's done, you let it cool a little bit. I did it before we started the lesson. So I've got my water in my kettle now, and then I'm going to very carefully unscrew the lid from my spice jar and pour the hot water. It's not boiling anymore, it's hot because I've let it rest for a bit, into the spice jar. Okay, so it's almost up to the top. And then I'm going to take my food colouring, and I'm going to put some of that into the water. So quite a bit, so we want the colour to be quite strong. So now my hot water is a nice reddish pink colour. And then I'm going to screw back on the lid from the spice jar and bring my container back round. Okay, so So now the water is hot in the spice jar, we're going to kind of plunge it into the container. And because this container is just water from the tap, so it's quite cold. And because it's hot water inside the spice jar, the water should start to rise. And because it's coloured, we should see that really clearly. Now, when you put it in, you might need to shake it a little bit once it's in the water, because some air bubbles can sometimes trap the water from coming out. So I'm going to do that now. Okay, and then hopefully you can see on your screens as well, be able to see that the hot water, which is the water with the pinky reddish food colouring, is straight away, it's rising right up to the top of the water and it's spreading out as well. So we're starting to create our own convection current. So it's starting to move round right up to the top and it's going to spread across. And then that's where our ice can come in. So this is optional, but if you want to kind of speed up the convection process, because eventually the hot water will kind of become the same temperature as the rest of the water. But if you want to speed up the process, you can add some ice, and that should start to send the pink red water back round in a kind of convection current. So I'll just wait for a little bit more of it to come up. Hopefully you can see it spreading all the way across the top. And then I'm going to start adding some ice onto this side. And we should see it starting to bend and come back down and around. So hopefully you can start to see it's getting a bit fainter now, it's mixing with the other water, but some of the red is starting to bend around underneath the ice here. So that's how you make your own convection current at home. I hope you enjoy recreating that, and please do make sure you ask an adult's permission and ask them to help you with the kettle to make sure you do it safely. Thank you so much for joining us for this week's class. We are extending the classes through the month of June, so we've just been planning what new lessons we have in store for you, so they're going to be up on our website by the end of the week. And if you have been signing up to these sessions via Eventbrite, I'll also send you an email to let you know what we have coming up too. So lots of exciting things in store, and we hope you'll be back to learn with us again. Thanks again for joining us. Do let me know if you have any questions before we end today's session. And as always, these lessons are completely free. If you would like to make a donation to Benjamin Franklin House, then you can do that on our website, which is www.benjaminfranklinhouse.org. And don't forget to get in touch if you think of any questions, or if you'd like to share feedback or any photos of you trying out the experiments.